Okay, so I would like to finish the topic about how you can define equals method for your class. Okay, let's review what we have achieved the last time. Remember we had the example project over here. Okay, example project here, two-dimensional points. I'm going to develop on top of that today further. Okay, if you look at that, let's review what you have to define, and then I will write some JUnit tests to help you understand a little bit further. So this is what we defined last time. First of all, we want to say basically like this. Under the context of point number 2, so it's a different class. If you simply just go to point over here, you can see point. There is no explicit redefinition of the equals method. So that means by default, it's going to call the inherited version from the object class. As we saw last time, it's going to compare just references between the two objects. That's not exactly what we really want, because we want to somehow to say this. If the 2 points got the same values for x and y, they should be equal. We shouldn't just compare the references. So that's why we created this point number 2 class over here. Okay? Over here, you can see that we can have this equals method here. You should notice that the equals method is Boolean. It returns true or false. And then it takes some object arguments over here. So now there are several things we have to do before we can actually retrieve the x and y. First of all, we say that if it happens that if the object we are comparing is simply just the object itself, in that case, it would just be true. Okay, let's test this right away. So we're going to write several tests to verify this point. Okay, let's just go to your test point here. So I'm just going to add a new test. You can see over here we got test default equals. So that's for the class point, not point number 2. Okay, so now we're going to write a test for that. Okay, let's see how we do that. Okay, guys, please. Okay, so now, let's now just write a new test. Test over here, let's say public void, let's test redefine equals. In Java, they call redefine, also called overridden. Overridden, or redefine, that means redefine. Overridden equals. So now over here, we're going to call a different version of the equals. For example, we can say point P1 is new point 2 and 3. Let's still build it up one by one. Now I want to say point 2 because I want to say this is a different class where we explicitly redefine the equals method, right? As you can see over here. You can see the equals method here. That's what we redefine explicitly. Okay, so now let me just go back there and then let's see what's going on here. Okay, let's just go back there. I want to fix the constructor. So that should be public in order for you to call that. Okay, so now let's go back there. Let's see, first of all, let's do something that's very trivial. I can say assert true. If I say P1 dot equals P1, I am expecting this one to be just true because P1 equals P1 is always the case because they refer to the same objects. Let's make sure this actually passes. Okay, that one's okay. Now let's do the second one. You can see, go back to point number 2. The second case we consider was, over here, we say that if the object you're comparing against is actually null, in that case it would be trivially false, right? Let me show you how. Over here, if I say over here, if I say assert, let me just say assert true for now. If I say P1 dot equals null over here. So now let's consider this assertion here. If I say P1 dot equals null, first of all, can P1 be null in this case? Cannot be, right? Because we did create P1 over here in the first line. So P1 cannot be null. Actually, to be more precise, if P1 was null, we wouldn't just get true or false. We would get something called null pointer exception because we're trying to call the equals method on something that's null. So it's a different issue here. Okay? So now, my point is, because we know P1 is not null, if you are trying to compare that with something that's exactly null, of course that will be false. Okay? So we should really assert false over here. Just notice the difference. Okay, let's try that. And we have still green bar, okay? Which means this returns true, just for the same reference. This returns false, also trivially, because you're comparing something that's not null with something that's null, okay? Let's see the other two cases, which is more interesting. Let's see the third case over here. In the third case, we're saying that we'll simply return false if we are comparing points with something that's not a point, something that's not really null, but just some object of the different type. For example, you might compare point with point 2. You might compare point 2 with a string, so they are different types. So of course, you cannot compare apple with banana, right, as I said. Let's see how this can return false. So over here, let's say string s, which is simply, let's say 2 and 3 over here, just that. Apparently, it's a string, right? It's a different type from points. If I simply say assert true over here, if I say p1 dot equals and then s over here. Okay, if I simply say that. Now, is this going to return true or false? Let's think about that. First of all, if you simply by looking at this, p1, it was declared as point 2. The type is point 2. S over here is declared of a string. You can see point 2 and string, they are of different classes. So they shouldn't even be compared. So we just return false, trivially. Okay? So now the one thing you should notice is the way we do this is by saying the context object, which is the P over there, say get class. So get class is just a method we are showing you can simply use. It's going to return back to you the current type of this object here, right? So now let me just make some point here. So p1.getClass will give to you point 2. Okay? On the other hand, if you say s.getClass will give to you string. Apparently, they are not equal. Of course, the equals method should really return false in this case. So what we should really say is not assert true, but assert false over here. Okay? Let's verify that. Okay? Let me give you another case. What about I say point 2? I'll say p2 over here. Let's say null point, just that. And I simply say this is assigned to null. Okay? And I'm going to run something that's very similar. P1, and then over here, I'm going to say null point. You can see somehow Eclipse does not complain, which means you're really passing some variable which may or may not store some valid address. In this case, null point stores just null, right? So now which case is it going to run? You can see that's going to go for the previous case, right? Even though you're passing some variable rather than passing directly the null. But because the variable stores null, so you'll go to this case over here. So it's still null. Any questions until this point? Are we okay? Okay. Okay, so that's about the case over here. Let's do another one. So now let's say up to now, if we are able to reach this point, let's say, reaching this point over here, which means we haven't returned either true or false up to now. Reaching this point, we know that this and objects are both not null, and they are of the same type. Okay, that's what we have. So now what's going to happen next is somehow, since we know objects, the type is actually a point. So we have to somehow retrieve its x and y and then compare, right? Okay. Let me first write the test cases, and I will show you why this line is necessary. So this is something called typecasting, which we'll mention maybe a little bit more when we talk about inheritance. But for now, I'll give you some intuition. Also, there will be some details on the slide you can read. I'll give you some intuition in just a moment, maybe on the iPad. So let's try something here. So now, why don't we try point 2, let's say P2. And then new point. In this case, 2 and 3. In this case, point 2. In this case, the equals should return true, because the x and y, they are the same. On the other hand, if I try another one here, let me just use another variable here. Let's say it's 4 and 6. Now for P3 over here, P1 dot equals P3 should be false, because even though they are of the same type, but the x and y values are not the same, so that should be false. Okay, let's try that. So what I can do is I can say assert true. I can say p1 dot equals p2. Okay, that's one assertion here. Even though they are of the same type and the x and y elements are the same. Okay, now let's try another one. I can say assert false, and then p1 dot equals p2, p3 over here. Okay, let's try that. Let's see what's going on here. Class cast exception. I think this one should be 0.2. Okay. The reason that, again, I should really talk about this. Maybe let me save this line for the iPad. Okay. Basically, what this line will do is somehow we want to make sure we can retrieve the x and y for the objects. Okay. I'm going to explain this in just a moment. Okay. Let me try again. The mistake I made before was I'm now in the context of point number 2 over here. So I should really cast that into the same class. But I cast that to the wrong class. If you watch a recording, you will see. Okay, so that should be 0.2. Let me try again. Okay, it's now green. Okay, so now let's try to understand why this line over here is necessary. Okay, that takes a little bit of explanation. But let me first ask for the 4 cases over here, 1, 2, 3, and also 4. For these 4 cases, any questions about them before I move on? For any of the equals method you're going to define for this course here, you're going to have all the 4 cases. Okay? The number, I would say number 1, number 2, and number 3, they're very much standard. They shouldn't be any surprise to you. It's only the number 4. After the cast, you have to somehow to compare the attributes that you need. For example, let's say, what does it really mean for 2 persons to be equal? Maybe their names have to be equal, their weights have to be equal, and their heights have to be equal. So you got different attributes to compare. Yeah.
So from the comment to before the cast,
Yeah.
you repeat that time.
Uh-huh.
You
Yeah.
have 6 times, right? So why we need the cast?
I will get to that. Yeah. When we say, somehow the type we are talking about now, we are being it's a very loose notion over here. So once we get to inheritance, we can be a little bit more sophisticated. But I'll try to explain that. It's a good question. Yeah. When I say the same type, they are not really the same type in some way. Okay. Yeah, I would say it's both yes and no. Okay. So now let's see. So you're okay with the test cases, right? Okay. So now let's try to see why we need that. Okay. Let me just use the iPad to explain to you. I forgot to open that. Give me one moment. Okay, not myself, over here. Okay, so now let's try to understand why we need a cast. Okay, let's just give a simplified version of the equals method. So now let's say we are now in the context of class point2 over here. Okay, and then now we talk about the equals method, right? We got Boolean, and then we have equals. And then remember the way we declare was objects, and then obj. Okay, so we got case 1, case 2, and case 3. I'm going to ignore them for now. Okay, and over here I got something like point 2. Other is assigned some cast over here, and then we have obj. Okay, and here it has to be 0.2. You can notice that somehow this class here, 0.2, is exactly equal to this class here. That's one thing to note. Okay, and then let me continue with that, and then I'll start explaining. So here you simply say return something like this dot x equals other dot x, and this dot y equals other dot y. Okay, that's the definition. So So now let's try to understand why we need this cast. Okay, so now this is how I would start. So now, first of all, when you look at this over here, I want you to first look at this line here. Object. Over here, what are we trying to do over here? When we say object obj, we are basically doing some declaration. We are saying that for this particular equals method, we're declaring a parameter called obj. It is of type objects, right? That's what we're doing here. Now, let me be a little bit more specific. The type I'm talking about now is called static type. Static type in the sense that the compiler, when you compile the Java code before you go to the runtime, this is what the compiler would know about. It's called static type. Okay, I'll write it down. It's also on the slides. In this line here, we declare obj of static type objects. Okay, so now the notion about static is very important. And then I'm going to show you another notion of type, which is called dynamic type. Okay, now let's think about how we use this. That's actually, I'll write it here. So now I'm just going to use this box over here. Imagine that this is where you're going to use the equals method. Okay, I just find a space here. Okay, let's say now in our test, right? We got our test method here. Okay, just another class. When we say something like this, when we say point p1 is assigned to new point 2, sorry, point 2, and something over here, and when we say point 2 and p2 is new point 2. Okay, let's say we do that. When we do these, you can see that again. Let's highlight these two things over here. Again, when we declare P1 and P2, they are of certain variables which can store addresses of point 2, right? Again, these two blue parts are also static type, okay? These are also static type. So now I want you to pay attention to these two things. Whenever we are using the new keywords over here, so that means we're creating some new objects in the memory, okay? Which means this is what we really try to achieve at the runtime. So the type of object you create in the memory is called the dynamic type, okay? So now I'm going to highlight these and then I will write it down. So now the point to over here is called the dynamic type. In this case here, it's actually quite lucky because the static type and dynamic type happen to be the same. In general, they do not have to be. There will be certain rules you have to learn later in the inheritance. But now I'll give you one example where they might be different, okay? For example, I can certainly declare something like this. I can say objects O3. Let me say P3. P3 over here is assigned to new point 2, and then something like this. This is legal in Java. This is okay, right? Again, let's think about, so this is the static type of P3, which is objects. That's where we declare. Whenever you declare something, that's called static. And now over here, you can see that we are using the new keyword over here, and this is what we do at the runtime to create the memory, to create the objects in the memory. So this is the dynamic type. Okay, I think as far as this example is concerned, I think that's good for now. So you got static, you got dynamic. Okay, so why is this relevant? The reason that this is relevant is as follows. In Java, whenever you're trying to make a method call, okay, this is the rules. Okay, so far so good. Let me just go to the next page. I think I need to just need another page to show you. Okay, let me just repeat that very quickly. So again, you have class point2. And then you have Boolean equals, and then objects obj. If you do this, and then we got 3 cases over here. And then let's say we try the following. Let's say without a cast. If you simply say return this dot x equals obj dot x, and this dot y equals obj dot y. If you simply do this, I think I tried this very briefly with you last time. You can also try that in Eclipse. If you simply write this down, it will not compile. Okay? Why? There is one principle for the compiler. Whenever you're trying to make a dot notation there, let's say obj.x. The context object is obj, and the attribute we're trying to look up is x. For compiler to decide if this line here is valid or not, here's the rule. It will look at the static type for obj. In this case, objects, not point2, right? Now, did we declare x and y as attributes in the object class or point2? Point2, right? Not objects. Object is basically the common superclass for every class. So there's nothing like x and y over there. So this line here will not compile. Let me write it down first, and then that can give you some intuition why we need cast. Over here, you can see obj here. The static type is objects. How do I know? Because that's exactly how it is declared. That's a static type. And now, whenever you're trying to call a method or try to access some attributes, what the Java compiler will do is to look up the static type, and which is very easy. You can just go to the declaration there, it sees it's objects. Okay? And object here does not declare, which does not declare x and y. If you think about, I will draw some diagram here. If you think about what the situation is, this is objects. That is the superclass of every class. And this is our point number 2. And in the object class, we did not declare anything called x and y. These concept of x and y coordinates only exist in point number 2, right? So only double x and double y, only here. So when Java compiler sees that, oh, obj here is of type objects, but object here does not include x and y. So this line would not compile. Okay, that's how Java compiler decides. You should really understand this first before we go further. Okay? Again, if something should compile or not, the only thing that Java compiler can really look at would be something called static type. Okay? When you go to 2001, later on when you learn about the theory of computation, you realize this addresses some limitation fundamentally for the computer. The best the computer can do is to base on the static types of the variable and do some analysis. You can never figure out what's really happening at the runtime. It's something called undecidability, which we'll learn in 2001. Okay? Any questions until now? Okay? So we want to know first why object.x and obj.y are invalid. First of all, the static type is simply not specific enough. It's simply just objects. It's not point2. So now, how can we, because we know pretty well, because the previous 3 cases did not really pass through, actually passed through already. So that means the object obj over here must be a point2 object. It must be. In that case, if we are pretty sure it's really point2, what we can do is we can tell the compiler, trust me, it's really point2. However, sometimes it might be wrong. Remember what I did before, I cast that to the wrong thing. I cast that to point rather than point2. In that case, there will be some runtime exception. Okay? So be careful whenever you do the cast. So now, how can we fix this? Okay, the way to fix this is, so this is the fix. Since the previous 3 cases not satisfied, we are sure obj is a point2 object. Okay, that's kind of the reasoning. Because we know it must be a point2 object. In this case, we can force a cast on the compiler. That's what we can do. That's our freedom. Of course, you're taking a risk. Okay? So now, this is what you can do. Again, so let me just do, again, another page. Okay, let me just repeat again. So class point2 over here. And then we have our equals method here. And then we have objects obj over here, and that's Boolean. Okay, so now we got the previous three cases over here. So now, because we're pretty sure it's a point2 object, so what we can do is we can just declare a new point2 object over here, just called other. And then we can say now we can assign to this particular version. Okay, we still got obj here, but now we are forcing the compiler to believe it's really a point2 object. We're doing casting. So what does casting really do? Somehow it temporarily changed the static type. Okay. So what this does is temporarily change the static type of obj from objects to point2. Okay, it used to be objects, but temporarily it's now point2. Once we have changed that, now we can call the .x and .y. Okay, that is why you will see that the last block of code will be simply return. Now let me use a different color. Over there, you can simply say return this dot x equals other dot x, and this dot y equals other dot y. Okay, before I take questions, there is some alternative form to this if you like. Let's say you don't want any intermediate variable like other over there. You can write it in another way. Okay, maybe this can help you understand a little bit better. Alternatively, this is what you can do. We can do the cast on the fly. I can say this dot x equals. I can now do the point2 cast over here, and then obj. Okay, and then I'm going to say do this cast first, and then dot x. Yeah, that means there's no other. The name of the reference, what do you mean? That's obj. Oh, I'm just saying alternatively. I'm just showing another alternative over here, yeah, right? Alternatively, we can say return over here, right? And then this dot y, and this dot y equals, and we got point2 over here, do the cast, and then dot y. I'll show you on the Eclipse as well. But these are two possible versions. You can do either one. I'll show you that on the Eclipse. Okay, I'll take some questions first before we go by the Eclipse. Yes? You know what? I would say for now, no. You have to follow some rules stringently. But I would say now, in this particular context for the equals, because of the previous three cases, remember we said this dot get class not equal to obj.getClass, because that one doesn't really return false. So now we're pretty sure they are of the same type. That's why we can safely do this cast. Okay? When we talk about inheritance later, we're going to talk about under the inheritance hierarchy there will be certain things you can do cast. There'll be certain rules you cannot do. But we'll talk about it. Okay. Any questions before I move on? Just move back to Eclipse. Again? No problem. So now, first of all, static type is very easy. This is already in another page. So basically, there are two kinds of types. So first of all, let me write it down. Static type and dynamic type. Static type is easy. That is the type during declaration. So for example, when you say point 2, and then you say P1, right? That's when you declare the point, right? In this case, the static type is simply point 2. And when you say, for example, person over here, and then you say Jin, and the static type is just person. Okay, that's static type, very easy. Dynamic type is a little bit tricky. I'll mention maybe I mentioned two cases for you, okay? Dynamic type can change. It's dynamic because it can, first of all, one thing about static type. Once declared, can never be changed. Can never be changed. So static type is really easy. Once you declare that, it's always fixed. So that means the compiler does not have to keep track of how you change the types, just when declaration. Dynamic type is tricky. Okay, let me give you this. There are two cases here. Case number one. Case number one, if I say point 2, P1 over here, I say that is assigned to new point 2, and say 3 and 4. Whenever you see a new keyword over here, the type associated with it is the dynamic type. Okay, that's always the case. So that's the dynamic type. That's case number one. Oh, okay, that's dynamic type. The second case is a little bit tricky. I'll just mention that. Don't worry too much if you cannot understand that fully. I'll just mention that. How do you change the dynamic type? So now you can always put objects as the static type because that's very general, right? That's the most accommodating static type. If you say object P1 is assigned to new point 2, and then 3 and 4. So now for P1, this is the static type, never changes. Okay? And what's happening now is P1 is now pointing to some point 2 objects over here. Point 2, basically whatever title you mention in the box, that's a dynamic type. Okay? So now you got X and Y, 3 and 4. At the moment, the dynamic type for P1 is just point 2. Now let me do something here. Let me use a different color here. If I do P1 is reassigned to something else, I can say, because P1, the static type is objects, I can assign anything to an object. Okay? So now I can say P1 is new person. And then I can say, for example, Jim. This is also valid. Oh, you know what? I forgot to change that. Thank you. I changed in 3311. Somehow I feel the class get bored so easily, so that's why I put the screensaver, actually. No, that's not true. I just forgot. Yeah. Anyway, okay. Now, I better change it, right? Otherwise, sorry about that. Okay. Oh, really? Okay, let's say never. Okay. Now, if we have that, so we know that it's going to be something like this. We have another object here called person, and then person has the name being Jin. Now we know that P1 is not going to point to this object anymore at the runtime. It's now going to point to this object here. So now it's pointing to a different box with a different title. So the dynamic type has now become person. Okay? So now from here to here, dynamic type changes to person. For case number 2, don't panic too much. You wouldn't see that until we see inheritance. But I would say, if you really want to follow that, feel free to drop by my office hour. I can explain more to you. Yeah?
So in the past, the dynamic type changes to the...
Only the static type.
The static type?
Yeah. remember it's a very good question. So remember in the previous one, over here, somehow the object here, if we are pretty sure object is really pointing to some point 2 objects, in that case, we can temporarily change its static type. Because its static type used to be objects over here. We can change it so that we can call the attributes. Okay, if you study the slides again, so I kind of repeating the points in the slides, so you can see that as well. Okay? Yeah?
Can we say that the left-hand side is static, right-hand side is dynamic?
You can say that, because remember in the assignment over there for single equality, always on the left-hand side, you declare the variable. But I would say don't worry about left or right. As long as you're declaring something, that's always static type.
So that's left-hand side, right-hand side.
Yeah, you can say left-hand side. Yeah, I'll say that's yes. Yeah.
So P2 is the remains generally after we change it.
You mean the P2? Good question. Let me just go back. So over here,
Or P1.
P1, no problem. Let's say in the red case over there, when I say object P1 is assigned to new point 2, in that case, the static type for P1 is objects. The dynamic type is point 2. Now let's move to the pink line over there. In that case, remember I said static type never changes. So its static type remains to be objects, never changes. But the dynamic type changes to person. So you can see somehow the static type analysis is much easier than dynamic types. That's why for computer, there's really some limitation of what they can do. They can only keep track of the static type, not the dynamic type. But that's kind of advanced. Any questions before I move back to equals? Okay, I want to mention one more thing in the Eclipse, and then I'll see what else on the slides I want to mention. Otherwise, we can change the topic. Let me just go back to point 2 here. I promise I will show you another version. So this version works. Alternatively, you can say this dot x equals. Now, if I say point 2. Yeah, sorry about the distraction here. So point 2 over here. Let me ask one question. If I say obj.x, this one here still does not compile. Right? Let's try to understand why. Remember the parentheses somehow will force the order of evaluation. Right now, what it will do is, it's not trying to do the cast first. It's trying to do obj.x first, which is illegal. Because objects, objs, the static type is objects, which does not declare x and y. So you have to really put the parentheses there. So that's important. So now if I do this, it will be okay. See? So that one's so fine. Okay, so the parenthesis is really important. So which means we want to cast first, and then inquire about x. Okay? Okay, and then we can say the similar thing. We can say this dot y equals. Let me close that. Point 2 obj, and then dot y. That's an alternative version. As you can see, somehow just got rid of the intermediate variable called other. But both versions are equivalents. It's really up to you which one you prefer. I personally prefer the first version, so I don't have to do the cast always. Okay? So it wouldn't be a bad test question. For example, if I simply just give you without that parenthesis there, I will ask you why it wouldn't compile. Right? So the good answer would be, you should say, it will try to do obj.x. In this case, the object class does not declare x, so you wouldn't do it. What you should do is, you should really put the parentheses around and then do .x. Okay. Any questions before I move on? Okay, well, I think I was pretty much doing a very detailed analysis for the equals method, but it's worth doing. Okay, let me just see what else to be talked about. Okay, I think everything is there, so let me just go over very quickly. Okay, there will be some other things. Okay, you can just go over this. Okay, that one we said already. So that's the equals method. Okay, and then okay, different cases over here, right? I'm just repeating in the slides. So now, so this is just textual description of what the equals method do. Okay, this one basically just talk about static type and also how you do the cast. Again, I said that already. So I would say I think something I mentioned in the iPad somehow extends a little bit to the slides, so you can look at both. Okay, finally, let's say how do we compare two persons? Okay, remember, let's say for the person class we got name, we got weight, we got height. We got 3 attributes over there. So now how do we compare them? So now the first step, we're gonna define. So let's say we got first name, or let's say we got first name, last name, weight, and height. We got 4 attributes. Let's say for two persons to be equal, that means their first name must be the same, second name must be the same, and weight and height must be the same. 4 things. How do we do that? Okay. So now equals method, it will still take an object, which means eventually we may have to do a cast, but this time to person, not point to. Okay. Now first case, they're always the same. If they are the same objects, return true. Second case, if the other objects is, let's have a look at this. Are you convinced somehow I combine the 2 cases over there, right? I say that I'm gonna return false under 2 circumstances, either because the object is actually null, which is the second case, right? And or this.get class is not equal to object.get class. There's a third case. I'm just combining them together using logical OR, vertical bar, vertical bar. Okay, I have a challenging question for you at the end, but I'll get there. So now, let's say I have line number 7, so now you can see I do the cast again, right? So this time I say, since if I can reach this point over here, that means it's guaranteed both are not null, and also they are of the same type. So now I can cast obj into person. And then I can simply do other.weights, other.heights, right? And now you can see that I'm calling the equals over here, right? So now let's try to figure out what this is trying to do. Where does these 2 equals method come from? String. Remember, string is a library class in Java. Presumably, the equals method for every library class has been defined properly for you. Otherwise, it wouldn't be a library class. So I would say whenever, if you're trying to compare some attributes of some library type, you can always just reuse the equals method there. You don't have to reinvent the wheel by yourself. Okay, that's my point. Okay. So now I have one question for you. Okay, I'll present a question here. So now, for line number 6, basically this line here, line number 5, there's a typo. If you can look at line number 5, it's a logical disjunction here. So now let's say if obj happens to be null, and if obj is null, then let me just present this question a little bit better. I'll put that in the iPad. Let's discuss that. It's also quite important. Okay, let's have a look. So now we say that, so basically it's like an else if, right? So here we'd say, sorry, I just forget. So obj equals null, or this dot get class not equal to obj dot get class. If this is the case, then I will return false. Right? That's one of the conditions. Now here's my question. What if obj is null? What's going to happen? Hold it. Anybody? Yeah? And the first one, which is going to return? Null is equal to null. Good. And then? Well, let's say this. If it is true, then if you try to evaluate the right-hand side, you're going to get this.get class. That's okay, because this cannot be null. If you say null.get class for the second part, would that give you a null pointer exception? You will not continue, right? Okay, how do you call that effect in Java? Anybody remember? Short circuit evaluation. Okay, can I just how about I do a very quick review? I think that's really important. Okay, for those of you who don't know about this, let's do that very quickly. Everything boils down into logic that you learn from 1090. Okay, let me do that very quickly. So first of all, the answer is no, because the short circuit effect. Okay, that's actually on the slides. Let me just talk about short circuit effect very quickly. I will just mention another use case of that after the end. We talk about conjunction, right? So now over here, let's say we do P and Q. Let's say P and Q, they're Boolean variables, right? So how many combinations do we have for P and Q? How many? 4, right? Okay, so now we got, let's say false, 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 true, true, false, and true, true. So now I'm pretty sure you know about the truth table. How many cases there will make P and Q true? Only one. It's only when both are true, right? I'm going to use green for true. The only case I can make it true is when both are true. Other than that, everything else is going to be false. Okay, what does that mean? That means as long as one side is actually false, it doesn't matter what the other side is. Okay, let's think about but afterward, Java is not really logic, it's really programming language. What does that mean? Java will be smart. Let's say we try to evaluate P and Q at the runtime. If P, we're going to evaluate from left to right, so P first. If P is already false, do we have to bother to evaluate Q? No. Logically speaking, it's going to be guaranteed to be false. So if P is false, no need to evaluate Q. If P is true, then we have to go ahead and evaluate Q. Okay, that's short circuit effects. Okay, so I'll just write it down. So P is true, P is false. If P is false, no need to evaluate Q. So similarly, if I got P or Q, how many ways can I make this P or Q false? One way, right? When both are false. So it's completely symmetric. So now the only way I can make both of P or Q false is when both are false. And then for other cases, it would simply be just green, true. So now think about this argument here. Again, at the runtime, I'm going to evaluate P first and then possibly Q, left to right. If P evaluates to true already, do I have to bother to evaluate Q? No, because logically speaking, if P is already true, doesn't matter what Q is. Overall, you'll be true anyway. Okay? So now, the argument is similar, and I'll show you some more example quickly. So which means if P is true, no need to evaluate Q. No need. Okay, I'll just give you one more example. So typically, you will see something like this. Let's say somehow you have this expression here. Let's say you have some integer I. Somehow maybe, let's say, read from the user. You can use scanner or buffer reader, whatever. Okay, let's say I is from the user. Okay, now let's say I want to somehow check the following. If I say if somehow 0 less than or equal to I, and I less than, let's say A is some array of integers, A.length, and AI is, let's say, positive. And then I'm going to do something here. Now, let's have a look at this. So we have conjunction, conjunction. So now think about what short circuit effects is doing here. What can it save us? So now, if I try to evaluate 0 less than or equal to I, which means it must be either at least 0, right? If it is not at least 0, which means it's negative, In that case, you're going to make it false, which means because short circuit effect, we will not bother to go any further. And now, question is, if I can reach this particular point, what does that mean? That means the P, the first one, and the second one are both true. If any one of them is actually false, I would have stopped already. But if I can reach that orange line to evaluate because of short circuit effects, the previous two must be true. Which means somehow I found a bound for I. It must be between 0 and also the length of the array minus 1, which means it's a valid index. Okay, so this means it's like a guard to ensure I is a valid index. Okay, are we okay for this? Let me make it slightly more complicated for you, slightly. Let me say that, can I say this is P, this is Q, this is R, P and Q and R. You learned that in 1090, P and Q and R should be equivalent to P and R and Q, for example, right? It's called the commutativity of conjunction, something like that, right? So now, let me ask you the following. Logically speaking, these two should be equivalents. If I say R and P and Q, right? I'm putting R first and then P and then Q. Logically speaking, there should be no flaw. They are equivalents. But what about in terms of programming? Anyone? Tell me what's wrong with having the blue version over there. I put the check for P and Q later, after R. So I'm pretty sure you know the answer. Let me delay that. Okay. Anybody want to try? Hint for you. It's going to evaluate from left to right. Let's say, what if I is negative? If I is negative, it's going to make P false. Don't you agree? However, when we get to P, that means we have already evaluated R. To evaluate R, we have to use A minus 1 larger than 0. We would have already got some array index out of bound exception, right? So this would not work. Okay? You can see the order of evaluation is important. Logically, it does not matter. But afterward, Java is not really a logical language. So you really have to pay attention to this detail. Did you learn about this in 1022? Yes? No? No? That's good. You're learning something new today. Right? No, don't worry. I'm not going to blame you guys. That's fine. It's tricky. So this one, no, because when R is less than 0, R will throw index out of bound exception. Okay, how about just one more? What if I do something like this? If I say if, over here, what about I say P and R and Q? Logically speaking, they are also equivalents. But now, give me a counterexample which will prove at the runtime this is going to fail. Good. You can see that over here. Let me just say that in words quickly. So now, over here, you can see that when we check P, we're going to check that it cannot be negative. Once it is true, we'll move to R. However, what if Q is not actually will give you false, right? Let's say if the value of I is actually way too large, it's actually more than the length of the array. In that case, it's going to make Q actually false. But it will be too late when you check that after you do R. Okay? I'll write it down. Okay, so that's not good. No, because when this should be I. When I is larger than or equal to a dot length, then you actually get trouble over here. Okay? Any questions? If you want to read more about short circuit, you can go to my background slides for the loops. I think there are many slides talking about short circuit effects. Okay. Any questions before I move on? Well, yes.
So technically, the one you showed on the null point, that if you switch around, that's a problem. The null position.
Sorry, say that again.
For the, you know, the one.
Yes, yes. There's the next question.
Switch that.
Mm-hmm.
You know.
Okay. So the question was, the concern was, let's go back here. Now you can see over here, let's go back to here. When we talk about disjunction here, we only evaluate the right-hand side over here when this is false. Agree? If this is false, that means the OBJ is not null. Now let's say we swap the order. Okay, that's basically a question. Well, let's say, I think it's here. I'll go to this slide in just a moment. I think there's one question there, I believe. I think, okay, short circuit effects. Okay, I think I'll just ask you this. Let's say over here, you can see this line number 5. If I swap the order of the two conditions, I would say this.get class not equal to obj.get class, vertical bar, obj equals null. Is it going to work? Right? Let me go back to the iPad and then let's have a look. Okay, this one here. So that was a previous question there. So let me just pose a new question. Now there's a new question there. Swap the order. Which means we're going to say this dot get class, I'll say get C, not equal to obj dot get class. Or obj equals null. Is this going to work? Well, to decide that, right, think about what obj equals null will do for you. Now, let's say if obj happens to be null, in that case, when you evaluate the left-hand side, it's going to give you null pointer exception already, right? However, in the original order, if obj happens to be null, it's going to be true, which means you're not going to bother to evaluate the second one, right? So the order does matter. Okay, so now in this case, over here, no. When obj is null, you have null pointer exception. Okay. This one's a little bit, theoretical, more detailed, but since it's called advanced object-oriented programming, right? It should be advanced. Any questions before I move on? Yeah. Exactly, because of that. But in the original order there, if obj equals null will give you true, which means you do not have to bother to evaluate the right-hand side. Yeah, that's exactly the reason.
You're going to put obj equal null at the back, so there's no point of putting that anyway, because it's always going to get.
No, you're going to put it because you want to make sure it's not null, right?
So it's like you put it on the back, so there's no point of putting it anyway.
Yeah, exactly, if you put it in the back. Yeah, I'm just trying to say sometimes you may just get the order wrong. In that case, you might get some exception, right? Okay, no questions? Are we okay? Good. Okay, let's move on. I think equals method, we are done with it. I think, so let me just go over this slide very quickly. So there are two notions of equality in Java. Either you can use equals, which will only compare values. But depending on the two sides of the equals. Let's say if it's obj1 equals obj2. In that case, you're comparing the addresses of the two objects. If you say obj1 dot equals obj2, in that case, it depends on the overridden, the redefined version of the equals method. Okay, you can just go over that. It's basically what we said before. Okay, if no question there, I'm going to move on to a new topic. Okay, I want to at least finish that today. Okay, it's something called call by value and call by reference. It's not a difficult topic, so I want to finish that quickly, hopefully. So now, I'm going to make the example code available to you, but let's see if you can just see the slides first of all. So now let's talk about some general concept. In general, if you try to make a method call, you will say some context object co dot some method n, and then it gives some argument value. It can be more than one argument. I'm just making one for now. So now, this is something that may be a little bit surprising to you. Somehow, when you pass some argument value, for example, you say increments and then have some object value there. I'll give you an example in just a moment. So somehow the point is, whenever you pass an argument value there, it's not passed directly to the caller, to the method. So now, instead, we have some copy of the value for the arguments to be passed into the method. Okay? I will show you an example. Now, first question for you. What can be the type of the argument value? Remember we talked about types? What are the two possible types in Java? It's either primitive or reference, right? If it's primitive type, it can be integer, char, boolean, etc. In that case, you simply just copy whatever the value is and then pass that into the method call. In that case, you will simply just copy, for example, number 2, character j, or true, right? Now, for reference type, I'll give you an example, but let's just see this. The principle is, reference type means, let's say P1. P1 stores only address of some objects of type point2. It does not store the address itself. It does not store the object itself. It only stores the address. Okay? So now, when we copy something called call by value, for the primitive type, we simply copy the value of the primitive type. And call by reference is, when we pass some object variable there, we only copy the address and put it into the method. Okay? So now, for example, if you see on Eclipse, the debugger, you'll see this is kind of the address. You can say this is a particular object of type points of this particular address. Okay, let's see example. This is what I want to do. Okay, maybe it's better to do some coding to wake everybody up, right? The first slide is really boring. It's just some general concept. But let's see example, then you understand what's going on here. I want to show you, first of all, some classes over here. Okay, let's go to Eclipse. You will see that I'll make this code available to you, but let's now just focus on what I'm typing here. Okay, so now we have another project here called example for call by value, call by reference. Okay, so now what I want to show you is this. First of all, we have a point class. Okay, like before, we got point, constructor, and move vertically, which will change the y value, and also move horizontally, which will change the x value. That's it, just the point. And now, let's say I got another utility class. Okay, I got 3 methods there. Okay, let's have a look at the first one here. Okay, we'll see one by one. The first one here is a mutator. It's called Reassign Integer. You can see we have some parameter here called j. And the method here simply say j is assigned to j plus 1. That's what it does. It seems like the method wants to change the value of the arguments. It seems like. But is it really going to do it? Well, let's try. So now what I want to do is, I want to go to the test and write it. Okay, let's write the first test. You also got it on the slides. You can also have a look at that. But I'm thinking typing that might help. Okay, the first one, let's say public void test call by value over here, and utility new util. Okay, we have an object here. Let's call the method. Integer I is 10. You can notice that I is a primitive value, right? Now, so let's say, first of all, let's assert something that's really trivial. Assert true, I equals 10. And that's obviously true. Now, let's say u dot assign int over here, and I say I over here. What's going to be the value of I after I call this? Remember in the util over here, what it is trying to do is trying to say whatever the j is, in this case is I, right? It's 10. I'm going to say j is assigned to j plus 1. Is it going to do I is assigned to I plus 1? Yes, no? The answer is no. Okay? I'm going to show you why, but let's see why. Let me see if that's really the case. What I can do is I can say it's still 10. It's not going to be incremented. True. Okay? So now let's go back to iPad here. I'll draw the diagram, and then we can go ahead to the second case. Now, call by value here is actually very easy. Okay, first of all, let's go back to Eclipse over here. So when we first declare I is equal to 10, what we have is this. We have, when you say integer, I is assigned to 10. In that case, we have an integer box called I, simply 10. Okay? And then when we go to the next line, when we say u.reassign integer I, remember I said before, call by value. It is going to make a copy of I. And then, in this case, when we go back to here, the parameter is called j. Every occurrence of j is going to be replaced by the value of I. Right? So you can think about, over here, we really have another box over here. So I is the arguments. And j here is the parameter. And it's also 10. You can see it's a separate copy. Right? So now, when we go to the method there, when we execute, when we say j is assigned to j plus 1, what does it do? Well, you simply just do the following to 11. Somehow you can say I there is unaffected. Okay? That's why when you see over here, you try to say I is assigned to 10, and then you pass I over here, even though the method is trying to change the parameter, but it's really changing a separate copy, not I. Okay? Is it clear? Okay? Now let's go back. Let's go to the callback reference, which is more fun. Okay? Now let's go back. Let's go here. Do something similar. Test public void test call by reference number 1. Okay? And I'm going to first of all show you some method here. The second method we're going to look at is this. So it's something called Resign Reference, which means we're going to take some point objects called Q. And then we're going to create just a new point, just called the MP. And then we're going to reassign Q into MP. It's kind of similar to when we say J is assigned to J plus 1. So now the question is, if I pass an argument P as Q, in that case, am I going to reassign P as well? That's the question. Okay? Why don't we have a look in Eclipse and then we'll draw the diagram. Okay? Over here, I'm going to say point P is assigned to new point. And then I'll say 3 and 4. Okay? And then I'm going to somehow say u dot reassign. Oh, I got to create that. Let me create that first. And then I can say u dot reassign the ref. And then I'll pass P over here. Right? Internally, they would say somehow Q is assigned to some MP, right? Remember that. Okay? Remember, if you see the util here, you're going to say Q is reassigned to some MP. Okay? So now, let's see what's going to happen here. Somehow we want to see if P has been really reassigned to other things. Okay? So what we want to do is, we want to know what's the address of P before this method call, and what's the address of P after the method call. Okay? Let's use a temporary variable to catch that. Okay? So I'm going to say this, point, so let's say the reference of P before, okay, is simply equal to P. And then when we try to execute this method over here, you can see the body over there, it says Q should be assigned to MP. But is that really going to reassign P as well? Is it going to? Well, let's see. So now we want to assert either true or false. I would say true or false, and then we'll say P right now is ref of P before. Okay, let me draw some diagram here to show you. Okay. Okay, let's see this. Okay, first of all, let's see this. When we have point P is a new point 3 and 4. What we do is, you say P here is pointing to a point object here. It has X and Y, 3 and 4. Okay, that's easy. And then the next line, when you say point P is new. Oh, beg your pardon. So here you would say ref of P before is simply assigned to P. As we learned before, what does this do? We're going to copy the address of P into that variable, which means after this, we're going to have ref of P before is going to point to the same objects. Okay, now here comes the critical thing. When I say u dot change, it's called reassign. Reassign the ref of P. What is this going to do, right? Let's think about what it does quickly. When you look at reassign ref, and then over here, so it's a void method here, and then you simply say point Q. And then you would say point, new point is assigned to some new point. We got 6 and 8 over there. And then you say Q is assigned to MP. That's what you have, right? So now, we want to know after this method call, is P going to refer to the new points, or P is going to stay there, right? That's our question. Okay, let's have a look. This is why it is important to understand call by reference. Okay, so now first of all, we want to know that call by reference. So call by reference, because the call by reference Q is going to be a copy of P, which means Q is going to point to here. So far so good? Okay. Now, when I say point MP, and then I'm going to have MP over here, is going to point to another point object over here. X and Y, and then I got 6 and 8. And now, here comes the critical thing. When I say Q is assigned to MP, what am I doing here? Am I changing P or only changing Q? Right? So Q is now pointing to where MP is pointing to. And P is still pointing to the same thing, right? So we are not really trying to make P point to another thing. We are not. Okay? So that's why when you say assert true, over here, when you say P equals ref of P before, this will be just true. Okay, are we okay? Okay, this is what I would suggest. Give me just 1 more minute. I'll just tell you what you should do before Thursday. Okay? So before Thursday, study these 2 cases, study the equals method, and you will see that in the slides over there, which I already updated. You will see that for the call by value, call by reference, I got all the code over here. Study them, and then we'll go over the last case, and then we'll move on to the next topic. Okay? Okay, see you Thursday.